What's up, everybody? Welcome back. I hope you're doing well. Today, we are doing titration. Now, this is a really fun lab. Some of you have done this. Some high schools even do this, but this is a very simple, very powerful, very visual, and very fun lab. And I hope you get to experience that. Try to have fun, but of course, make sure that you understand what you are doing. And of course, make sure that you are safe. We have to make sure that we're being careful. But especially since we're dealing with acids and bases. So, what is titration? Well, let's get started here. So, titration is, in this context at least, the addition of an acid to a base or a base to acid. And the way we add that acid or base is what we call titration. So we titrate, meaning that we add a little bit, little by little. That's what titration is. One by one by one by one. Why are we trying to do that? I'll tell you in a minute. But let's go back a little bit and talk about acids and bases. What is an acid? What is a base? Now, as usual, you should have a full lecture talking about acids and bases. So this is just a quick recap, right? So an acid is traditionally something that tastes sour, it dissolves metals, and can cause plant dye to change color. And bases are they taste bitter and they are slippery and corrosive. But in terms of chemistry, you have different people defining them, right? So you have Arrhenius, Bronsted, Rari, and Lewis. And what you need to know mainly here is that an acid, right? According to Arrhenius, not Arrhenius, but Bronsted, this is the modern definition of an acid, which is it's a proton donor. What is a proton? If you remember, it's a hydrogen atom. So if you have a base and an acid will give away its hydrogen atom, and the base will accept the hydrogen atom, right? So if you have an acid, just use like general definitions, right? So an acid is something that gives away. So an acid is something that has hydrogen and hydrogen atom, and it tends to give it away. Right? That's the definition. And a base is something that tends to accept a hydrogen, right? So H plus then becomes BH plus, right? This is the general definition, right? So if a acid binds to a base, guess what happens? Well, an acid is gonna do what an acid does, which is give away its hydrogen, and a base is gonna do what a base does, which is receive hydrogen. So it's going to become A minus plus BH plus. So what I just did is I just combined these two reactions right here. This is what we call an acid base reaction, right? So I took an acid here, I took a base here, right? And then it gave me something, an acid that has lost its hydrogen, it becomes a base actually. It becomes what we call a conjugate base. And a base that has lost its, that has gained an electron, now it becomes an acid. Why? Because acids are things that have hydrogens to give, right? So I have this here where I wrote down that an acid gives away its conjugate base, and then a base gives away its conjugate acid. In this case, an acid is binding to water. So, water, the beauty of water is it can act as an acid or a base, it can receive and give away its hydrogens, right? So, there's a lot more to say about acids and bases, mainly that there are strong acids and weak acids, and strong bases and weak bases. And we learn about the reactions between them and all that stuff. But we are not talking about it today. Today, what I want to talk about is a little bit more about acid base reactions, talking about neutralization and titration. What is that? If you take an acid, right? If you take an acid, especially strong acid, right? So if you take an acid, strong acid, right? As I just did earlier, right? If you have an acid and then you add a base, right? As we talk about, an acid will give away its hydrogen and the base will receive that hydrogen. So they kind of work together. And when you have a strong acid and a strong base, it will be even better. Why? Because strong acids and strong bases, a strong acid will be something like HCl, right? The characteristic of a strong acid is because it gives away, it dissolves fully rather than partially. So it's going to give away all of its hydrogens and all of its chlorine rather than, if you have a weak acid, it's going to dissolve partially. A strong base is different. A strong base is NaOH, for example. A strong base is going to have a hydroxide, right? All of the strong bases will have hydroxide on them, right? So NaOH is an example, right? So NaOH is going to give away, right, Na plus OH minus, right? Well, something very interesting happens when you take a strong base plus a strong acid. What happens is that, if you can see, I don't know if you can see this, but this is H plus and OH minus. Do you know what that gives us? It gives us water. So if you take HCl plus NaOH, guess what you get? You're going to get, so hydrogen binds to OH to give us H2O. That's water. And then guess what? Chlorine binds to Na to give us NaCl. All right. So I don't know if you guys saw what just happened here. We took HCl, which is very dangerous, right? HCl is pretty dangerous. Then we added NaOH, which is pretty dangerous. And guess what we got? We got H2O, which is water, and NaCl, which is salt. So if you take a strong acid, you add a strong base, you're going to get salt and water. That's why we call it neutralization. We made it neutral. If you know about pH, you know that an acid has a very low pH, base has really high pH. But when you neutralize them, they become neutral. Neutral pH at pH 7. It's really cool. It's a really cool reaction that we're going to get to see, right? So neutralization reaction is you take an acid base, you get salt and H2O, right? So that's the neutralization reaction, right? So again, we have HCl, NaOH gives you NaCl plus H2O, right? And these will be, into ions. So H plus Cl negative, Na plus OH minus. So we'll get to talk about net ionic equations, right? A net ionic equation is an equation that shows you only the things that have changed, right? So if you have chlorine negative here and chlorine negative here, we're not going to count them. But again, that's another story in terms of net ionic equation. But we have a neutralization reaction, right? Neutralization reaction. Why does neutralization reaction have? Why do we care about neutralization reaction? We care about neutralization reaction because we can use it. We can use it to study the relationship with with between a certain acid and a certain base. What do I mean by that? If you look at this here, right? So we have HCl again plus NaOH becomes NaCl plus H2O, right? So we have 1 mole, right? If you remember stoichiometry, I know that you guys have studied this, but if you remember stoichiometry, we are saying that 1 mole of HCl neutralizes 1 mole of NaOH. This is a balanced reaction, right? 1 mole of HCl neutralizes the 1 mole of NaOH, right? Meaning that if you have, right, everybody, I want you to pay attention to this. If you have a bucket of NaOH and you don't know how many moles are in here, everybody with me? You can add HCl, your HCl solution that you know the moles of, right? You can add your HCl. Let's say you add HCl here, right? And then you add that's the titration. You add HCl until this is neutral, until the solution is neutral. If you add the HCl until the solution is neutral, and you know the number of moles of HCl that you've added here, right? Let's say I added like 10 moles of HCl for it to become neutral. It took 10 moles of HCl to neutralize this unknown NaOH. If we know that 1 mole of HCl neutralizes 1 mole, and it took 10 moles of HCl to neutralize NaOH, then how many moles do you think we had here to begin with? 10, right? 10 moles. Because 1 mole neutralizes 1 mole, then if we added 10 moles to neutralize NaOH, then our NaOH concentration has to be 10 moles. Right? So we use this method to measure the concentration of unknown acids and bases by titration. That's the whole idea between titration, and that's what you are going to be doing. But in order to do that, we need to have a titration setup, and you need to understand how do we know that we have neutralized our unknown solution. The way we're going to do it is we're going to do titration. How do we do titration? We do a titration setup here with something we call a burette that you should have in your kit, right? So we have a burette here. Then we have a beaker. Not bigger. We're going to use a flask. A flask is much better, right? And then what we're going to do is you're going to add your known concentration at the top, right? We're going to add your unknown concentration at the bottom. And very importantly, you're going to add something we call a indicator. Something that changes color when you reach a certain pH. In this case is pH 7, because we need to know when the solution is neutralized. Right? Now you're starting to understand, right? So we need to know when the solution is neutralized, because when the solution is neutralized, it changes color and then we stop. Right? So we use a color indicator. Right? This one that we're going to be using here, again, should turn pink. It turns pink when you reach the equivalence point, right? So the equivalence point is the point at which all of the acid has neutralized the base or the base has neutralized the acid. So the equivalence point. So we have equivalence point where there is a color change based on an indicator. We need to be familiar with these terminologies. Right? Everybody with me? So that is the titration setup. Even though it doesn't look like this, but we are about to do it in the lab, and I'm about to show you in the video how it looks like. And you are going to assemble it, and you're going to be able to do this. But two things. Number one, it's very hard to catch the indicator, so you're going to do two determinations. One will be very quick and dirty, where you're going to be doing it quickly so that you can see where the color is. And then after that, you're going to be doing it more carefully so that you catch a more accurate color change. Because we don't want a dark pink, we want a light pink color. When you do a dark, when you get a dark pink color, then you've already went past your equivalence point, right? So I want us to get a really good light pink color so that you can get an accurate concentration. So that takes me to the next step. How do we calculate the concentration? All right. So if you have done your titration correctly, right, which I know you will do, we are going to do this. We are going to be like, okay, you've added, so you're going to have your burette here, right? And then you're going to take a reading, right? The first reading and the second reading of the burette. And then you're going to know how much you put in your flask. Ooh, that is not a good drawing, but it's hard to draw this way. But okay, so you will know how much you put in your flask, right? It's a little bit better. So you know how much you put in your flask. You know how much you put in your in here, right? You're going to titrate until the color change. So you will write down the beginning and the end of your color, right? So let's say you start at 0 milliliters and then you end up with 17 milliliters here. And then here you started at 10 milliliters, right? So let's say this is an acid, right? So I think I gave you an unknown concentration of acid, right? So acid is unknown. So it's HCl, but the concentration in molarity is unknown, right? And then we're adding or titrating NaOH. What's the concentration of NaOH? Let's say we have, I don't know, 2 molar, right? And then the volume of NH that you've added, you will know because you did it yourself, from the beginning to the end. Let's say we have 17 milliliters, right? And by the way, this is going to be held out by like a stand that I'm gonna give you. It's not going to be floating in the air. But if you have this, you have made this experiment, then you should be able to calculate the concentration of the unknown acid. Why? Because if you remember here, right, the moles, it takes 1 mole of acid to neutralize 1 mole of base. So it takes 1 mole of base to neutralize 1 mole of acid, meaning that the moles, the number of moles added will be equal, right? And guess what? If you remember back in your formulas, you remember that the moles, right? The moles are usually, right, N for moles is equal to the molarity times the volume, right? What does that mean? It means that, so if the moles N of the acid is equal to the N of the base at equivalence point, meaning after we've neutralized, this is true. If that is true, then the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. This is the whole point of titration, guys. If there is a formula to get from this, it's this formula right here. I love this formula, right? Why? Because look at this. You have the volume of the acid, right? The volume of the acid, you have it. The molarity of the base, you have it here, right? The volume of the base, guess what? You have it here. So all you need to do is find the molarity of the acid. So from here, for example, the molarity of the acid is going to be equal to the molarity of the base times the volume of the base over the volume of the acid. And you have everything here. So that is how to calculate the volume of the acid from titration, right? So now you know the idea about titration, you know the this titration setup, the equivalence point, the indicator, how we do it, and most importantly, how we calculate the concentration of our unknown entity after we've done the titration. And now you should be ready to get started. So without further ado, let's begin.
For this lab, you're going to have your acid and base solution as well as an indicator. You're also going to have some sort of pipette in order to add your solutions to the beaker. And speaking of that, you should have a beaker and a flask. And on top of that, you always have your goggles and your gloves for your protection. And you're gonna have a stand, a metal stand, its base, as well as a plastic burette. And you're also gonna have some sort of connector to connect your metal stand to the burette. Some of you have this type of traditional metal connector, but some of you have 3D printed plastic connectors that should be even easier to connect to your burette. So to get started, as always, put on your gloves and goggles, right? As seen in the video, Alex is doing a great job. And after that, again, put on your goggles and gloves and then start assembling your stand. So you're gonna have your ring and then the base, and then you're going to take them out of the bag and then you're going to connect them, and they should go together just like that, and they're just easy to snap right into each other. That is your stand. And after you stand, you're going to add the connector to the stand. Again, you might have a plastic connector. Just make sure that you connect it. On one side is going to be the metal stand, on the other side is going to be your burette. Make sure that your burette is straight, make sure that it's tight, make sure that it doesn't shake. And the burette is actually not plastic, it's glass, so make sure that you don't drop it because it's going to break. Make sure that your burette is in the closed position. So if you look at the fountain, the little fountain at the bottom, it should be in the closed position before you do any experiment. And at the bottom of your burette, you're going to have your flask and your beaker. To get started, as discussed in the introduction, we are going to try to titrate our known concentration of base into an unknown concentration of acid. So that will inform you where we add the acid, where we add the base. So if we titrating something, we're going to put it in the burette. If we are titrating to something, we're going to add it into the beaker or the flask. So at first you're going to add your acid, your unknown acid, into the flask, and then you're going to add an indicator. So we're going to use an indicator in order to track the pH change. For this because we're using a very small volume, add one drop, just one drop of your indicator, right? So one drop of your indicator, no more than that. One drop of your indicator, and then the volume specified of your HCl. And after you add your HCl, you are ready to add your NaOH. So go ahead and add your NaOH, right? After adding the indicator, add your NaOH on top, right? I think the procedure calls for about 10 milliliters. So make sure that you add your 10 milliliters into the Erlenmeyer flask along with your one drop of your indicator. Put it right under your burette. You are then going to pour your NaOH into the burette, right? So to pour the NaOH into the burette, first you gotta make sure that it's clean. You gotta make sure that it is closed. It's in the closed position, which is horizontal. And then you're going to add a funnel on top. You should have a tiny funnel in your kit. If not, that's okay, because we are going to use those little dropper bottles that should fit right in there. And then you're going to add about 20 milliliters, right? And it's very important after you pour to write down the reading of your burette, right? So you're going to record the reading of your burette in your notebook, as Alex is doing in the video. And then after that, you are ready to do your first titration. So your first titration happens after you have acid. So your unknown solution is in the burette. You added the indicator. You added the base. The acid is in the beaker or flask. The burette contains the known concentration that you're going to titrate, and then now you're ready to start titrating, as long as you added the indicator as well. Make sure that you have recorded the starting volume, because we're going to record the end volume so that we can know. And then you start titrating. And as you titrate, we are looking for a color change that doesn't go away. So as we start titrating, you'll see that the color changes, but when we mix, the color goes away. So we're gonna have to keep doing that. But since we're going to do two of them, the first one you're gonna do it quickly. All right? You're gonna do it quickly, and you're gonna keep going until you get to a color change that doesn't go away. So you're going to add like 1 milliliter. Stop, mix, and as you can see, whenever we mix here, it goes away, right? Until we get to one that stays, right? Until we get to a color change that stays. So that's right there where we get to a color change that stays, doesn't go away. And that color change right there indicates our equivalence point. But the color change right there is too pink. And too pink means that we have surpassed our equivalence point. So we need to record our volume, the volume that we have added, so that we get a rough idea of where the color starts to change, so that next time we're going to be more careful when we get there. So we're going to do another titration after we have recorded the start and the end of our titration, right? After we have recorded the start and end of our volume, we know how much we've added, so we're going to do it again. So you're going to rinse your beaker. You can keep the same NaOH in your burette, but if you need more, you can add more in your burette, and then you can do another titration from start to finish. And the second titration, you got to be careful, because again, let's say you figure out that last time we added 10 milliliters. This time we are going to add about 8 milliliters, and then when we get there, we start to add it drop wise. Why? Because we want to catch a lighter color, which will be even more accurate. So when you do it, you should get a color that looks like this, right? A color that looks like this, just light pink, right? And this only comes when you are very careful and you start to slow down when you close. So this should be on your second titration. If you don't get a nice light pink, you can do another titration, but please don't do more than three. I don't think we have enough material for that. Just record your data for the three titrations. All right. And then after that, you are done with your titration. You have hopefully had a successful first titration and you're ready to clean up. So make sure that you disassemble your stand, clean your burette really well, clean everything else, and you are good to go. Make sure that you dispose of all the chemicals. You can pour them down the sink as long as you add a lot of water, and then keep the chemicals that you haven't used. And after that, you should be done.
All right, that is titration. I hope you enjoyed it. I hope you got a good pink color. And make sure that you fill in the data, do the pre lab, do the post lab. And as always, reach out to me if you have any questions, concerns, comments. And I will see you in the next lab.